Hello folks! This is Mike coming back at you with another video on Foundations of Math numero dos. In this video, we are going to talk about exponents, properties of exponents, as well as scientific notation. So before we get into the scientific notation piece of this, let's introduce some properties of exponents first. Just as a bit of a recap, we mentioned this earlier on. For any positive integer n, a with the number n in the upper right hand corner is basically just saying we're going to multiply a by itself n times. So if n was 3, we'd have a times a times a. If n was 5, it'd be a times a times a times a times a. We call a the base, we call n the exponent, and we say it's a raised to the power n, or a to the nth, or a with exponent n, various ways to say the exact same thing. Now for some properties, for any positive integer n, if you have a to the power minus n, that's the same thing as saying 1 over a raised to the power n. So if the exponent is negative, the way that you can make it positive is to send it down to the bottom of your fraction. If you had a negative exponent on the bottom of your fraction, you can make the exponent positive by putting it up to the top. So say I had 1 over a to the minus second. This is the same thing as saying a to the second, or a squared. For any non-zero number a, if you take any number that's not 0 and raise it to the power 0, you're going to get 1. And now 3 important properties of exponents that we are going to be using in this video. First one up is the product property. The product property says if you're going to take the product of two things and those things have the same base, then that is the same thing as the base raised to the sum of the powers. So a to the b times a to the c is going to equal a raised to the power b plus c. Second one, the quotient property, very similar to the product property, but not quite the same. If you're going to take the quotient of two things that have the same base, then that's the same thing as that base, a raised to the difference of the two powers. So a to the b divided by a to the c is equal to a raised to the power b minus c. And then the third property, the power property, says if you're going to take something that's already raised to a power and you're going to raise that thing to some other power, that's the same thing as the base raised to the product of those two powers. So a to the m raised it to the nth is equal to a raised to the power m times n. So now here's where the scientific notation actually comes in. If we have a really, really large number or either a really, really small decimal, we often write these things using scientific notation, simply because it's just not as nice or not as easy to write out all of the digits that are involved in either the very large number or the very small decimal. How do you know when a number is in scientific notation? A number is in scientific notation if it's written as a decimal with one non-zero digit written to the left of the decimal point, and then it's multiplied by some power of 10. I've provided some powers of 10 here. 10 squared is 100, 10 cubed 1,000, 10 to the fourth 10,000, to the fifth is 100,000, and to the sixth is 1,000,000. And then some negative powers as well. 10 to the negative second is 0.01, 10 to the negative third 0.001, 10 to the negative fifth 0.00001, so on and so forth. Just some kind of basic powers which you can reference. So here's where we get into some actual problems. How do we take a number and turn it into its equivalent but in scientific notation. The first thing you're going to do is you're going to take the decimal point and you're going to move it left or right within your number so that there is only one non-zero number to the left of your decimal point. Step 2, you're going to write that resulting number times 10 raised to some power. But now the question is, what is that power? If the decimal point was moved to the left, the exponent on 10 is going to be the number of places that you moved that decimal point. If you move the decimal point to the right, then the exponent on 10 is going to be the negative of the number of places that you moved that decimal point. So we're going to do a couple samples now to see how this all works out, how we actually do these things. So first up, the number 47,210,000. We're going to write that number in scientific notation, and then we're going to write the number 0.00047 in scientific notation as well. So starting off with 47,210,000. Right now, our decimal point is right here. I have to move this guy to the left. And I'm going to move it to the left until there's only one number to the left of that decimal point. So I'm going to move it to where it's right there. So as you move this, you can actually do this on your paper, or you can just count inside your head and just go 1, 2, 3, 4, 5, 6, 7. I still do this myself. I still actually write this out so that I know either that or I do count inside of my head how many places I move that decimal over. So in scientific notation, the decimal point is now here. So the number that we write before the power of 10 is going to be 4.721 times 10 raised to the power of, well, we moved the decimal point left and we moved it 7 places. We counted out those 7 places as we moved our decimal point, so it's going to be 10 to the 7th. So in scientific notation, this number is 4.721 times 10 to the 7th power. Now, going on to the next one, 0.000047. Right now, the decimal point is right there. I need to move this decimal point so that there's only one digit that's not 0 that is directly to the left of our decimal point here. So I want to get it to be right there. I have to move this guy right. Let's see how many places I have to move it right. 1, 2, 3, 4, 5. So, again, the number before the power of 10, 4.7, times 10 raised to the power, well, we moved it 5 places, but we moved it right 5 places. So the exponent is not going to be positive 5, but it's going to be a negative 5. So in scientific notation, our number is 4.7 times 10 raised to the power of negative 5. Now, how can we go the opposite way? How can we go from scientific notation to decimal notation? And just for clarity, decimal notation is how we typically write our numbers. 0.12345 or 15,700,500, something like that. Just how we commonly write our numbers. It gets done one of 2 ways. If the exponent of 10 is positive, then you're going to move the decimal point to the right the same number of places as your exponent. And you may need to add some zeros in at the end as placeholders until you've used up all of your number of moves, your number of digits there. If the exponent of 10 is negative, you're going to move the decimal point to the left the same number of places as your exponent is. And you also may need to add more zeros as placeholders when you've used up all of the digits in your number. So here's a couple examples of that right there. We're going to write 9.12 times 10 to the 7th in decimal notation, and then we'll write 1.58 times 10 to the negative 5th in decimal notation. So first up, 9.12 times 10 to the 7th. Now, I already put some placeholders in there just by looking at this, by looking at the exponent. I have to move it right 7 places, and there's only 2 digits here, so I know that I'm going to have some kind of placeholder in there. So here's where my decimal was. I'm just going to move it right 7 places. 1, 2, 3, 4, 5, 6, 7. So the decimal point that was there is now here. And now the question is, what is that number? 91200,000 or 91,200,000. The other one here, 1.58 times 10 to the negative 5th. Looking at this exponent, I know that I have to move it 5 places, and I'm moving it to the left. This is where my decimal is right now, so I'm just going to move it 5 places left there, and again, you see that I added in zeros. 2, 3, 4, 5. So that's where the decimal point is now. Now, you could put a 0 out in front of here if you want, if you like to write your decimals with a 0 in front. If you don't, that's perfectly fine too. Don't have to do that. But as a decimal, this is going to be 0.0000158. So those were our couple sample problems writing things in decimal notation. Next, I want to talk about how do we multiply and divide numbers that are in scientific notation. Not as bad as you may think. We're just going to use some of those properties of exponents that we talked about at the beginning of this video, as well as just other basic properties of multiplying and dividing. So you do this using the commutative property of real numbers and our exponent rules. We simply multiply, or we divide, in that case, the numbers before the multiplication symbol, and then we add the exponents if we were multiplying, or we subtract the exponents if we were dividing. We add or subtract those exponents of 10. Now, you may need to change the exponent of 10 depending on the result of multiplication or division. We'll see some examples where we have to do some tweaking. So first, a couple examples finding the product of two numbers in scientific notation. 3.4 times 10 to the 6th times 2.17 times 10 to the 9th. Let's find what that guy is in scientific notation. So all we're going to do is we're just going to take the product of the 3.14 and the 2.17. That's going to get me some number. I'm then going to multiply these guys here, the 10 to the 6th and the 10 to the 9th. And when we multiply those, We're just adding those exponents. So that's exactly what we did here. 3.4 times 2.17, then 10 to the 6th times 10 to the 9th. If you do 3.4 times 2.17, you will get 7.378. When you do 10 to the 6th times 10 to the 9th, you get 10 to the 15th. Now, we see that when we multiplied 3.4 and 2.17, we did get a number that only has one digit to the left of that decimal point. That's perfect. That's what we want in scientific notation. We don't have to mess around with this exponent anymore. For the second one here, we're going to start off the same way. I'm going to do 5.8 times 8.12, and then I'm going to do the 10 cubed times the 10 to the 5th. As you see right here. When you do the 5.8 times 8.12, you get 47.096. When you do 10 cubed times 10 to the 5th, you get 10 to the 8th. But this right here is not valid for scientific notation. And it's not valid because we don't have just one number immediately to the left of our decimal point. We have two numbers. So what I have to do here is I have to take this decimal point and move it to the left one spot. So that now there's only one number to the left of that decimal point. We only have that 4. But since I moved this decimal point to the left one here, I have to add 1 onto my exponent here. For every decimal point you move left, you add 1 onto your power. For every digit you move your decimal point right, you take 1 off of your power. So 47.096 times 10 to the 8th is equal to 4.7096 times 10 raised to the 9th power. And this is what we want in scientific notation. This is the correct way to write it. Some examples with dividing. 3.4 times 10 to the 6th divided by 2.7 times 10 to the 9th. Again, similar. I'm just going to do 3.4 divided by 2.7. And then I'm going to do 10 to the 6th divided by 10 to the 9th. So when I do 10 to the 6th divided by 10 to the 9th, I'm going to be subtracting those exponents. 3.4 divided by 2.7 is 1.259, and that 259 pattern does indeed repeat. And then 10 to the 6th divided by 10 to the 9th is 10 raised to the power 6 minus 9, or negative 3. Looking at the number in front here, we do only have one digit to the left of our decimal point, so it's fine. We don't have to move it, and thus we don't have to mess around with this power of negative 3 here. The second one, if you do 5.8 divided by 8.2, and then 10 cubed divided by 10 to the 5th. 5.8 divided by 8.2 is 0.70731, and 10 to the 3rd divided by 10 to the 5th is 10 raised to the power 3 minus 5, or negative 2. But this is not good in scientific notation, because the number that we have to the left of our decimal point is a 0. We can't have that. So I need to take this decimal point and move it one spot to the right. Now I have a non-zero digit to the left of my decimal point. That becomes 7.0731. Since I move my decimal point one digit to the right, I need to subtract 1 from my power. So my exponent will now be 10 to the minus 3rd. So our final answer, 7.0731 times 10 to the minus third. Lastly, where do we use scientific notation for the most part? Scientific notation does get used a lot in the sciences. Very small decimal constants and very large numerical constants happen in chemistry and physics, as a couple samples here. In physics, you do work in various areas with the speed of light. And the speed of light, the letter we use to stand for that constant is little c, and it's approximately 3 times 10 to the 8th meters per second. That is 300 million meters per second, approximately. And in chemistry, the number of atoms in a mole is equal to 6.022141179 times 10 to the 23rd. That is a very, very massive number. I can't even begin to say what that's going to be written as a decimal or as a typical number. And when I say 1 mole, I don't mean those things on your face or the things in the ground. It is a special chemistry term. So that concludes our video on scientific notation. Guys, if you have questions or comments, please be sure to reach out to me. Emails, text, postcards from the other side of the country, shout really loud, messages in the sky, messages in the ground, whatever you think will work. Otherwise, until the next video, take it easy, guys.